All right, guys, we are looking at basic concepts of probability and counting, the fundamental counting principle. This is day 1. We're going to get through examples 1 through 4 for section 3.1. Just some vocab that you need to read up on. It's stuff that you basically already know. I mean, you do probability, I think, probably every year before you get to me. The only thing that you might not know is a simple event is an event that consists of a single outcome. And so that might be one that you don't know. I mean, sample space you've heard from before, outcome you've heard from before or heard of before, so we should be okay. All right. These first few are just us looking at each type of experiments and then determining the number of outcomes and identifying the sample space. So, a probability experiment consists of recording a response to the survey statement to the right and the gender of the respondent. Okay, so we have 3 responses. You have yes, no, and not sure. And just for the purposes of this example, we're just going to deal with male, female, okay? So we could have the respondent be a male who says yes, a male who says no, or a male who says not sure. And then we could have female who says yes, female who says, female who says no, and then female who says not sure. So we actually have 6 total outcomes in our sample space. Okay. The next one, a probability experiment consists of recording a response to the survey statement to the right. So again, those 3 things, yes, no, or not sure. And then a geographic location. So we have northeast, south, midwest, and west. Those are our options. So they could come from the northeast and say no. They can come from the northeast and say yes. They can come from the northeast and say not sure. They can come from the south and say no, south and say yes, south and say not sure. They can come from the Midwest and say no, Midwest and say yes, Midwest and say not sure. And they can come from straight up west and say no, west and say yes, and west and say not sure. Okay, again, I had the choice of geographic location and then their responses, and with that, then I have, if you count them all up, I've got a total of 12. Okay, all right, heading to the next example, I think. Sorry, guys, I didn't realize I hadn't zoomed in to take care of that space, so you're gonna have to watch it zoom in. Sorry. All right, you ask for a student's age at his or her last birthday. Determine the number of outcomes in each event, then decide whether each event is simple or not. Explain your reasoning. Okay. The student's age is between 18 and 23. Inclusive means that I will include 18 and 23. If it said exclusive, then it would just be 19, 20, 21, or 22 would be the possibilities. But because it's inclusive, I include 18 and 19. So 18, 19, 20, 21, 22, 23. Okay, and so there's 1, 2, 3, 4, 5, 6. There's 6 total possibilities. And because there's 6 possibilities, it is not a simple event. Okay? Simple event is literally when you only have one option. Like the next one where the student's age is 20. That is your only option. This is a simple event. Okay? All right. Pressing the wrong buttons. Sometimes it isn't practical to write out the list of all the outcomes. So we use the fundamental counting principle. If one event occurs in M ways and a second event occurs in N ways, you literally are just going to multiply the 2 events together to get how many events that could occur. So for example, if I had 10 pair of pants and 5 shoes, I could make 50 different pairings. Okay? And yes, you have seen that many times before. So if we look at example 3, you are purchasing a new car. The possible manufacturers, car sizes, and colors are listed in the table. How many different ways can you select one manufacturer, one car size, and one color? So there are, 3 manufacturers. So we've got 3 for that first choice. And there are 2 car sizes, so times 2. Then there are, we'll go green, 1, 2, 3, 4 colors. So 3 times 2 times 4 is 24, right? So that equals 24 total possible outcomes or ways that you can choose a car, okay? You add another manufacturer, Toyota, and another color, tan, to the choices. So instead of 3 colors, in 3 manufacturers, I now have 4 manufacturers times the 2 car sizes times the 5, I want to match my colors, times the 5 different colors that you have to choose from, okay? And so that is a sample space of 40. And you would not, you wouldn't list it out the way that I listed out that first example, okay? All right, so when we do this, okay, how many license plates can you make when a license plate consists of 6 out of 26 letters, each of which can be repeated? So can be repeated. So what we've got is basically you've got a license plate, okay, that is going to have 6 blanks. So 1, 2, 3, 4, 5, 6. You've got a license plate that has 6 blanks. And you've got 26 possible letters for the first blank, 26 possible letters for the second blank because you can repeat them, 26 for the third, 26 for the fourth, 26 for the fifth, and 26 for the last one. And that is, I got to look at the note page because I already wrote it down. I'm not going to do that in my head. So 308,915,776 possible license plates. Okay. Then your next one, you still have 6-digit license plate. 2, 3, 4, 5, 6. This time you cannot repeat. You cannot repeat. So you can have 26 options for your first. You use a letter, so you only have 25 options for the second. Just 24 options for the third. 23 options, 22, and down to your last one where you only have 21 options left. And that cuts you down to 165,765,600 possibilities. Still a huge number of possibilities. All right, 6 out of 26 letters. So we're doing 6 again. We've got a license plate that's got 6 digits. And so we've got 1, 2, 3, 4, 5, 6 blanks to fill. All right. Each of which can be repeated, so we're totally allowed to repeat, but the first letter cannot be A, B, C, or D. So this first letter is actually going to, it's not going to be out of 26, it's going to be out of 22 because we can't use A, B, C, or D. But then after that, we're back up to 26 because we can use all 26 letters and we can totally repeat, okay? And when we do that, we get 261,390,272. And then last but not least, so 1 digit, any number 1 through 9, and 5 out of the 26 letters. Okay, so we still have a 6 blank license plate. Okay, this first blank, okay, and it doesn't matter. I'm just making it the first blank because that's where it fits. So this blank right here is going to be a digit 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 choices there. And then I need 5 letters. And so when I do the 5 letters, let me find another color. There we go. We'll go purple. So when I find the 5 letters, those can be repeated again. So times 26 for each of them, right? And then that will give me 932,000. I wrote 23. 32,384 options.